Welcome to an example in which we are solving a system by substitution. Notice it says up here. And there's the systems. This is two equations and two letters. Okay, you can see the answer is already down here. How'd they get that? Well, basically, step one, see how y is already alone right here? Step one is really just to notice y is alone in the second equation. When you've already got one letter alone in one equation, you're going to plug that into the other equation. So step two is going to be to plug y into the first equation, meaning y equals 7x plus 13. So I'm going to plug that in right there for y, right? Because this says y equals 7x plus 13. So that means wherever we see y, we're able to replace it with 7x plus 13 because y is equal to 7x plus 13. It's the same as 7x plus 13. So when I take that top equation, which is 3x minus 4 times y equals minus 27, bigger there, I can plug in 7x plus 13 right there for y. That making sense? Right there. So just plug that in. In fact, actually, it'd probably be better if I did it in two steps. Let me just do it a little more slow. Just want to make this super clear. So at first, this is 4y. And so then I go 3x minus 4. And then right there in the place of y, I put 7x plus 13. Okay, now what comes next? Distribute that minus 4. So it'd be minus 28x is minus 4 times 7. And then minus 4 times 13 would be minus 52 equals minus 27. Okay, so now 3x minus 28x is minus 25x. Minus 52 is minus 27. Okay, so step one was just to notice that y was already alone in the second equation. Step two is plug y into that first equation. And now we can solve for x, right? Try to get x alone here. Just add 52 to both sides. And what do we get? These cancel out. This is minus 25x equals, what is that? I think that's 25, isn't it? You know, minus 27 plus 52 is, yeah, 25. And then so last step, to get x alone, divide by negative 20. Boom. X equals negative 1. So, and that's in fact the x answer. So x is negative 1. Okay, so we have one more step now. So step one, notice y is already alone in the second equation. Step two, plug that y into the first equation. So plug that y up here into the first equation. Now we solve for x. So now step number 3, come over here. Yeah, so step number 3. Plug x in anywhere. Really, you can plug this x answer that we just got, this negative 1, in anywhere. Now, the easiest place is going to be where y is already alone, this one right here, since we're trying to find y. So I'm going to grab that one. Y equals, what's that bottom right, this one right here? 7x plus 13. Y equals 7x plus 13, because we're trying to find y. So the easiest place is going to be to go where y is already alone. Plug in there for x. Negative 1, because now we know x is negative 1. So y is negative 7 plus 13. Y is 6. There we go. So the answer to this question then is negative 1 comma 6, because it's x first, then y. And they want us to, you know, put a put a parentheses around it. So put parentheses around it, -1, 6, x comma y. And that is indeed the end. You would click right here and go -1 comma 6, as we can see the answer right there. That's x and y. That's the answer to this equation. By the way, also, I want you to see that, well, let me recap real quick. So step one, notice that y is already alone in the second equation, right? Already got y alone. Plug that y into the first. So grab this, plug it into the first. We did all that here, and we got our answer for x. And then step three, plug that x in anywhere to get the other letter y. By the way, those two answers make the equation true. I want you to see that. So x -1. So if I put -1 in for x everywhere and 6 in for y everywhere, this is -1. Do you see how it makes it true? Makes both equations true. 3 times -1 is -3. Minus 4 times 6 minus 24. -3 minus 24. Yeah, that's -27. And 6 equals -1 times 7. -7 plus 13. That's 6. Yeah. See, this is the solution for x and y that makes both equations true at the same time. That's what it means to solve a system. You find the answer that makes both equations true at the same time. If you're interested in the behind the scenes stuff, what if we were to graph this? We're not going to graph it, but if you were to graph it, what you would find is one of these is one line and the other one is another line, and the point where they meet and intersect is the point back 1 up 6. That's what it is. When you have two linear equations, two equations whose graphs are lines, and you graph them, the point where they intersect is the solution to the system, because that point's on both lines. That point makes both equations true. That's the one point that makes both equations true. Anyway, all that's not necessary. Just notice y is alone in the second, plug y into the first equation, and then step 3, plug x in anywhere to solve. So the reason that works is because that gets it down to just x, and we're able to solve. And there we go.